Hi everyone, this is Kavita, a final year computer student from Welfare Institute of Science, Technology and Management. I am going to share our final year project that is Comparative Analysis for Mining Frequent Item Set Algorithms. Here is the team details. Our team guide is CH Devi Madam and our team leader Devi, team members myself, Pushpalata and Shaila. And coming to abstract, in our project we discussed about the comparative analysis of algorithms for finding frequent item sets. Frequent item set means searching for recurring relationships in a given data set. Several algorithms have been proposed to mine all the frequent item sets in a transaction table. And here we are using three algorithms, namely a priori algorithm, FP growth means frequent pattern growth algorithm, and vertical data format algorithm, which gives the details about the efficiency of each algorithm and helps to decide the most optimum algorithm. Now coming to the introduction, frequent item set mining is an important operation that has been widely studied in many practical applications such as market basket analysis. Given a transaction table in which each transaction contains a set of items, frequent item set mining returns all sets of items whose frequencies in the table are above a given minimum support count. Here, the existing system can be classified into two groups, candidate generation based algorithm and tree based algorithm. The candidate generate based algorithm first generate candidate item sets, and these candidates are validated against a transaction table to identify frequent item sets. And tree based algorithm do not generate candidate sets. They construct a special tree based data structure to keep the essential information about the frequent item sets of the transaction table. Now coming to the existing system, in existing system they used a priori and frequent pattern algorithm. Here a priori algorithm is a candidate generation and frequent pattern is a tree generation, and these are for finding frequent item sets based on transaction database. Each algorithm is used for finding frequent item sets. In this we have seen that a priori have some drawbacks comparing to the frequent pattern algorithms. A priori algorithm performs multiple scans for generating candidate sets, while in frequent pattern growth algorithm it scans the database only twice. Coming to proposed system. Present in our project, we are comparing different types of algorithms for finding frequent item sets, namely a priori algorithm, frequent pattern growth algorithm, and vertical data format algorithm. Then also we compare these three algorithms on a large data sets and will show you which algorithm is best for large data sets, and also shows the which algorithm gives the best result for finding frequent item sets. These are the three algorithms which we are using in our project. A priori algorithm, frequent pattern growth algorithm, vertical data format algorithm. Now explain the each algorithm. First of all, a priori algorithm. A priori algorithm is for frequent item set mining and association rule learning over relational database. It proceeds by identifying the frequent individual items in a database and extending them to large and largest item sets as long as those item sets appear sufficiently often in the databases. A priori uses a bottom up approach. A priori algorithm is a two-step process, namely join and prune. The join step generates k plus 1 item set from k item sets by joining each item with itself. The prune step scans the count of each item in the database. Now coming to the flowchart, a priori algorithm flowchart. Here first we have to create the transaction table and now calculate the transaction table with some item sets, and we will give the minimum support count. If the minimum support count is greater than the item sets, If the item set is greater than the minimum support, then we will continue the process. If the item set is less than the minimum support, then we will remove that item and insert the items to frequent item set. Now we have to find confidence for each non-empty subset. We will give the minimum confidence, and if the item is greater than the minimum confidence, in continue the process. If the item set is less than the minimum confidence, remove the subset and stop the. For example, here is the input. We have given some transaction IDs and the item sets, and given some item sets, and here is the process. First we are using two candidates. Here we are using support and confidence. If we give the minimum support is true, we will search the item sets which are recurring the same relationships, and we also finds the confidence which have the which have equal item sets. So by doing this process we get the output, and this is the process we have done. Now coming to the frequent pattern growth algorithm. Frequent pattern growth algorithm is proposed by hand. It is used for finding frequent item sets in a transaction database without candidate generation. FP growth constructs a tree. It is an efficient and scalable method for mining the complete set of frequent pattern growth. Frequent pattern tree is a tree-like structure that is made with the initial item sets of the database. The purpose of the FP is to mine the most frequent pattern. Each node of the FP tree represents an item of the item set. And here is the FP growth algorithm flowchart. First we have to start and take the one transaction table, and we'll give the minimum support. If the item sets are more than minimum support, we will continue the flow. If the less than the minimum support, then discard the item. And here we will create the list by descending order and sort the items in a transaction based on F list. Now construct the FB tree, and we'll give the minimum confidence, and in this process is same as a priori algorithm. In this, if the item set is greater than the minimum confidence, we will continue the flow. Less than the minimum confidence, discard the items and construct the conditional FP tree. Generate the frequent item set. Stop. And here is the same transaction table which we have taken in the a priori algorithm. The transaction IDs have given and the list of and here is the tree which we are using in the frequent pattern growth algorithm. By using this tree, we will construct the FP growth algorithm by. Here is the tree, here is the item IDs, support count, node link. From this we will take the each item as a node and we will construct a tree. And this is the output which have done by the FP tree. Here we taken the some transaction items and we have given the minimum support, and these are the relations which have given most support and confidence. These are done by the Vector tool. Now coming to the vertical data format algorithm. Vertical data format algorithm is used for mining frequent item sets. The horizontal data format of the transaction database is transformed into the vertical data format by scanning the dataset once. And mining can be performed on this data set by intersecting the TID sets of every pair of TID sets means transaction ID sets. Frequent single item with minimum support count. In this method, there is no need to scan the database to find the support of item sets. The TID sets can be quite long, taking substantial memory space as well as computational time for intersecting the long sets. And we can use this technique called and we to further reduce the cost of registration long TID sets as well as the subsequent cost of intersection. We can use a technique called diffset which keeps tracks of only the differences of the TID sets. In before algorithms, we have seen that each one is calculating equal, which items are equally taken as a support and count, but in that we have taken the transaction IDs which are equal, but in this vertical data format we will take which are not equal subset items by reducing the time which have taken to the algorithm. And here is the vertical data format flowchart we have taken it, and this is same as this is from the a priori algorithm. And here we have to start and transform the horizontal formatted data into the vertical data format, scanning the database. And here also support of every item is calculated, and we will give the minimum support same as the a priori and FP algorithm. If the minimum support is less than, if the items are less than minimum support, remove the items or insert the items and generate the candidate set same as a priori algorithm. And here we using extra technique, use diffset technique, insert items of frequent item set. Stop. Here diffset technique means in before algorithms we are taking equal items, but in this we will take the separate which has, and here is the input we have taken the transaction table and IDs and list of items, and this is the same as the a priori algorithm, but in a priori algorithm we have taken the transaction IDs, but in this we will take the remaining item sets, and here is the output. Now comparing these three algorithms, we have to comparison of three algorithms. A priori algorithm, it is simple and easy to implement and understand. It uses a breadth first search and it uses two steps like join and prune. But in FP algorithm, it is faster than a priori algorithm. No candidate generations. It scans the database only twice and it will comes from the depth first search. Calculate. Vertical data format. It is easy to understand. It is reduce the cost of registration of long TIDs. We can use a technique called diffset which keeps a track of only the difference of TID sets. In a priori, it requires large memory space and it generates candidate sets, and in FP take less memory and it constructs a tree, and it uses divide and conquer method. Vertical data format, it is a faster than FP growth algorithm, and it also reduces the size of the memory. And comparison of execution time, here we have seen that support threshold a priori have taken the more time, and FP3 is less than the a priori time, a priori algorithm, and vertical is FP3 algorithm is less time taken than the a priori and the vertical, and vertical is taken as taken less than the a priori algorithm. So by this we have given the execution path, that is and here is the video. We have taken the Android prompt Miniconda software and we are giving some commands, that is we are giving the Jupyter notebook to get into the Python. Yes, here. Now first we have to first we have to run the a priori algorithm. So a priori algorithm is in desktop and remaining files are to use to run the algorithm. So we select the desktop and we take an a priori algorithm. Here we have created the data set, that is stored underscore data dot csv. In this we have given the transactions. There are 7,500 transactions. In that we have given 1,000 minimum support. By this we have run the data and printed the output is here. Here is the output. They are printing the numbers. We have given the minimum support 1,000. Here support means which items are more frequent, and the confidence is which two items are which more which two items are more frequent to chance to frequent. And here and these three algorithms are comes from association rule. So here association rule equal to a priori and we have given the minimum support. And these all comes from the given data set. And now coming to the FP growth algorithm, and here also we have entered the program and run. Here the time will not be taken as much as a priori algorithm, and that is the now conclusion. In this, after the comparative study between the three algorithms, it is easy to decide that frequent pattern growth algorithm is more efficient compared to the a priori and vertical data format algorithm. So here we have learned that a priori algorithm have the transactions, and we have also shown that in the before video a priori algorithm have taken more time, frequent pattern growth have taken less time, while comparing to the vertical format data algorithm. And in a priori algorithm, we have seen that the candidate sets that are generating the item sets um, by breadth first search, and it also forming by step. And in the FP growth algorithm, it have tree based, so it will take the less time. And in vertical data format algorithm, it does not calculate the transaction IDs, it calculates the item sets which have taken less. And here, and these three algorithms are useful for many softwares, and it will easy to in market and market businesses like market basket analysis we have already said in before introduction. uh, and it will very useful for some companies which are selling their products without by calculating this we will save our time, our money, and we will there is no chance to loss. By this we also see the customers happiness, and we also save their time by doing this frequent item sets algorithms.